This is AS Pure Maths. We're in chapter 4 vectors and we're looking at applications of the vector product. So in the last video you were learning what the vector product was, the cross product. You multiply these two vectors and it gives you a vector as opposed to the dot product, which just gives you a scalar. The area of a triangle, as you know, is given by a half AB sine C. If therefore you have a triangle OAB, then the area of the triangle is given by a half OA times OB sine the angle in between. Now if the position vectors A and B relative to O, or A and B, then the area of a triangle is a half OA OB sine theta. So that's the same then as, well, remember we find the magnitude or find the length of that line, so that's the same then as magnitude of A, magnitude of B sine theta. And obviously our product rule, this is it. So half, sorry, for the vector product, not the product rule, but our vector product then is a half that. So the area of a triangle is a half A cross B. On to the next page. If you have a triangle ABC where the position vectors A, B and C relative to the origin are O, A, B and C respectively, then the area of the triangle can be calculated in a similar fashion. So in the previous one, I'll just go back to it here, we had the origin here, so it was just this one, in this one. In this next one, none of the three corners or vertices of the triangle are 0, so they're given them by A, B and C. So obviously we need to try and find AB and AC. So how do we get the AB? It's going to be minus A plus B, so that's my minus A plus B there. And then how do I get then the AC? Minus A plus C, so minus A then plus C there. But effectively it's just the same thing then as before, and we work them all out from there. So it's B minus A. If you wanted to multiply this out, that's all fine. I probably wouldn't be bothering with all this and kind of multiplying it out, but you can see it is going to give us then just what we need in terms of that. And so it's easier if you find the vector AB and find the vector AC and then work it out then from there. Let's take a look at a couple of examples. Find the area of a triangle OAB where O is the origin, A has position vectors 2i minus j plus k, and B has position vector 3i plus 4j minus 2k. So our area then is given by a half, and then it's going to be the determinant of, sorry, the modulus, so I'm getting these mixed up, 2i minus j plus k cross 3i plus 4j minus 2k. You can just about see the line then going down there. So how do we calculate that? Work out our modulus. Sorry, we're going to determine it. I can't speak here. 2 minus 1, 1, and 3, 4 minus 2. So that's going to be I upon 2, take away 4, so minus 2, minus j, minus 4 minus 3, so that's minus 7, plus k, 8 minus minus 3, so it's going to be 11. So our then it's going to be minus 2i plus 7j plus 11k. So our cross product here, where are we, of this and this, has given us this. We need to find then the modulus of that, or sort of the magnitude of that, and then find half of it. So our area then is going to equal half minus 2i plus 7j plus 11k, and that's going to be half on the square root of minus 2 squared plus 7 squared plus 11 squared, So it's going to be half upon the square root of 174. Alright, example 2 is a bit like then the other one that we looked at. Find the area of the triangle ABC where the position vectors of A, B, C relative to the origin are this, this, and this. So I'm going to call this A because it is, B, and C. So if we want to find the vector that gets you from A to B, that's going to be, so how do you get there? Again, we can take a wee look. This was our diagram, remember, from the last one. It's minus A plus B, or if you want, then OB take away OA. So we're going to write take away OA. So that's nice and straightforward. So it's going to be this vector, take away this vector. 3i take away 2i is going to give us 1. We'll write this just in column form. Minus 4 minus 5 is minus 9. And then 2 minus 1 is going to then give us 3. What about the vector that gets us from A to C? So that's of course OC take away OA. This one, take away this one, minus 1 minus 2, so that's minus 3. 2 minus 5, that's minus 3. And minus 1 minus 1, so that one now is going to be 0. So the area that we're looking for is a half AB cross AC. So let's find our determinant. I, J, K, 1 minus 9, 3, minus 3, minus 3, 0. So that's going to be, so that's going to be 9i. For the j, that's a 0, and then that's, so it's minus 9j. And then the k, what's that going to be? Minus 3 minus 27, so minus 30k. So we have that. If we go then back up to here, our area is going to be a half 9i minus 9j minus 30k. So that's equal to a half 9 squared minus 9 squared plus 30 squared. And that tidies up. You put it in your calculator, whatever way you want to work out. You get 3 over 2 root 118.